Hello friends, here's a question asked in Neet 2023 Physics, and the question belongs to chapter Electrostatics, and the question asks about the concept of Gauss's law. The question states if E dot ds over a closed surface is equal to 0, that the surface integral of electric field over a surface is 0, then what is the true among these statements? The first statement is the magnitude of electric field on the surface is constant. If the magnitude of electric field on a surface is constant, then E dot ds is 0. Let us see, is it possible? We are taking a case here as an example, a sphere here, and it encloses a charge Q. If you see, according to Gauss law, the flux linkage over the surface, over the sphere, will be surface integral E dot ds, and that will be equal to charge enclosed. This is a statement of Gauss law. Here the charge enclosed is Q. So this integral will not be equal to 0 in case electric field magnitude is constant. So this is not possible where integral E dot ds is 0. The case second says all the charge must necessarily be inside the surface. This is contradictory on its own. If a charge is enclosed by the surface, then necessarily there will be some net flux linkage over that surface. It is a basic statement of Gauss's law. So this is contradictory again. It is never possible. This case is never possible. The third case is electric field inside the surface is necessarily uniform. Let us see it. Let us take a case where electric field due to charge is not uniform. It is non-uniform. If we again apply Gauss law, surface integral of electric field over this surface will again be charge enclosed by this surface, that is Q, not equal but not be equal to 0. So it is not necessary field lines must be uniform. They can be non-uniform. It only tells us that surface must enclose a charge. Whether its electric field is uniform or non-uniform, it is irrelevant. So this statement is again contradictory. Field can be uniform or non-uniform. The condition is charge must be inside the surface. The fourth case is number of flux lines entering the surface must be equal to number of flux lines leaving it. Let us see this case. This is a possible case. Why? Because if we take as an example here, case 2, here's a sphere and a charge lies outside this sphere. The number of field lines entering the sphere is equal to number of field lines leaving the sphere. So let us analyze this sphere. Let's take this half part and then this half part and observe what net flux will be over this surface. If we take this half sphere, here the field lines and surface vector will have same direction. Their dot product will be positive. And same lines are entering here. But the surface vector and field, they have opposite direction. Their dot product will have negative value. If the dot product of E dot ds for the this half sphere is some positive quantity q1, and for this half quantity it will be minus q1. So net flux will be q1 plus minus q1, that will be 0. So this is a case where integral over the surface is the sum of all the E dot ds over this surface, that is E dot ds. It will be 0 only this case where number of field lines entering the surface is equal to number of field lines leaving the surface. Or in other cases, here the surface is not enclosing any charge. So this is the right answer here. Hope you understand this and found this video useful. Do like it. Thank you.